The next topic is multi-threading in Python. And here I'm going to talk about how you can implement multiple threads using a single program to do work parallelly. But before that, let me take a step back and tell you the concept of processes and threads. So far, we have not used processes or threads for that matter. But as I'm talking about multi-threading, you should know what are threads and what are their parents, which are processes, and how to implement multi-threading in Python. Process is basically the program that is getting executed in the operating system by CPU. As simple as that. Now, if I have to tell you pictorially, so let's say this is our storage that we have, and we have written multiple codes in Python in our exercises, and we store them in our hard drive, which is basically the storage. Let's say the name of the code is 3IAM Python Advanced.py, and this is the code that I have written and I have stored in my hard disk. But what happens is that when I want to execute, I open this code in an IDE called PyCharm, and then I execute it from the IDE. We can also use the command line to execute a program. But essentially, what is happening? What happens behind the scenes when you execute a program? Because it is in storage or in a hard disk. And of course, we have our RAM or our processor or our motherboard, whatever you want to call it. This is the compute part of our laptop, desktop, EC2 instances, virtual machines, etc. And we can have one or more processors, and of course we'll have RAM. There are a lot of other components also which I'm not showing you here, but these are the most important components. And whenever you switch on your operating system, either in your laptop or EC2 or anywhere for that matter, the operating system runs in the RAM by default, because operating system enables us to do whatever we do using virtual machines or in our laptops or in our desktops. So we need to have the operating system running. And by the way, operating system also runs as a process. Now let's say I want to run this program 3IAM Python Advanced.py. What would happen is that whenever I execute the program, I actually ask the operating system to execute it. So what the operating system does, it pulls the program from the storage. And after pulling it from the storage, operating system places it in the RAM. And this is 1 to 4. I'll talk about what this 1 to 4 is, but essentially the program is placed in RAM. Now, this is of course not the .py file, it is the machine executable code that we have been talking about. And then this code gets executed by one of the processors. There can be 4 processors in a CPU or 8 processors in a CPU, depending on what kind of machine you are using. So whenever this program gets executed, it needs an identity, because the CPU needs to know that what is the program it is executing. Now what happens is that we run hundreds of thousands of programs in a CPU, in a single laptop or in a single machine. If not hundreds, at least we run tens of programs in our laptop or EC2 instances or any virtual machine. So the processors need to know which one it is executing. So that's what a process is, and it is identified by process ID, and the process ID for this program which is getting executed is 124. So this is basically the identity of the program or the code that is being executed by a processor which is there in RAM. So the program is pulled in the RAM and then it gets executed by the processor. So there should be a way to identify this program individually. So it should not get mixed with other programs that are getting executed. And that's why it is identified by processes, and each program that is getting executed gets a process ID or PID. And there are various ways to look at processes. In Unix, it is ps-ef. We can use this particular command and find out the processes or the programs that are getting executed. You might have seen me running this command ps-ef in multiple cases, but basically this is used to find out the processes or programs that are getting executed in the machine. And ps.ef is Unix operating system. If you are using Windows, then we'll have to use something like Windows Task Manager. And if you are using Mac OS, you can use Activity Monitor, which is similar to Task Manager, or we can use ps-ef also, because macOS is Unix based. Windows also gives a shell a command line, and Unix commands can be run there also. So if you do not want to use Task Manager, and if you want to use Unix based commands, you can use this ps-ef in Windows also, using the shell command line that is provided by Windows. So all right, let me show you how do we see the process. Again, I am using Macintosh operating system, so I'll be running Unix commands, and it is more or less similar to that of Windows also. If you are Unix, Windows shell or Windows shell based command line. And this is the terminal, and if I type ps-ef, it is telling me all the processes or all the programs that are running. Now as you can see, there are a lot of programs running in my machine. Why? Because of course I am running a lot of program, I'm running a lot of applications. Not only that, the operating system itself also runs a lot of programs or system programs which are there. But anyway, using this ps-ef command, we can find out the processes or the programs that are running. And in Mac, we can use this activity monitor to find out the processes that are running, the amount of CPU that it is taking, the amount of threads that each process is running. Again, I'll talk about threads in the next video, and the percentage CPU that each process or program is taking, also the amount of memory that is being taken by each process and programs. It is similar to Windows Task Manager. If you use Task Manager, you'll be able to see the processes and threads also. Either you can use the Task Manager directly, or you can press Ctrl Alt Del and then you can get the Task Manager. So that's what a process is. So a one-line definition is that it is the program that is getting executed currently in the operating system. And each process would have its own identity, and that is called process ID or PID. Now the next thing is obviously threads. What are threads? I talked about processes, then where does threads come into picture? A little bit more background on the process, because we need to know that to understand what threads are. So let's say I am running only two processes in my operating system for simplicity's sake and for this example. Let's say these are the two processes that are being run in my operating system. And of course, these two processes are getting executed by the processors or CPUs. And then there's memory also, which is basically the RAM. Each process would have its own memory area, because whenever you execute a program, I told you how a program gets executed. We have temporary memory area as stack, then we have memory area called heap, etc. I have also told you the memory management of Python and how variables are stored in memory. So each process would need memory also, because each process is a program, right? So now here I am running two processes, and what would happen is both the processes would have their own memory area. So there would be a small memory area for P1, which is process 1, and memory area for P2, which is process 2. And these memory area would be used by the individual processes. Of course, these two processes cannot take the entire RAM, because there are operating system processes which are also running, and you might be running other applications also. So they'll get certain amount of the entire RAM that is available in your server or in your machine. Now, what are threads? We actually run threads inside of processes, and a single process can run one or more than one threads. So a single process can have anywhere from one to even hundreds of threads, or maybe no threads at all. Now in this case, process 1 is running 3 threads, and of course they would also need memory, and the same memory would be used by all the threads. So each thread will not get its own memory area. They'll use the memory area which has been assigned to the process. Now let's say in this case process 2 is running only one thread, so this thread of process 2 will get the memory area, entire memory area of P2. But in this case, for process 1, as we are running 3 threads, each thread would get certain amount of the memory area which is assigned for P1 or process 1. Now the question is, what is thread? Thread is a part of a process to execute a portion of the code. That's what a thread is. Typically what happens is that you execute the entire program in one go. In that case, there won't be any threads as such. But there are applications or complex applications which would spawn multiple threads. For example, in data engineering itself, let's say if you use Spark and if you run Spark, you would see that the main process of Spark would be spawning multiple threads, because each thread would do certain work assigned to itself, which would execute a different block of code. Very complex applications might have multiple threads. For example, databases for that matter, like DB2 uses something called thread-based model, wherein you have a single process and under that process hundreds of threads would be running. So if you want to use a particular feature of DB2 database, then that feature would be handled by a separate thread than the other threads that are running. And similar is the case with other databases and other applications also. For example, PostgreSQL does not use thread, they use individual processes. And same is the case with Redshift also, because that's a spawn of Postgres. Redshift also uses multiple threads. Of course, we cannot see that because we cannot log into the Redshift operating system, but that's how it works. But the crux of the matter is that you'd use thread to execute a portion of the entire code. And in Python, when you use thread, we mainly use it to execute code in parallel using multiple processors. Because most of the computers or the servers or the virtual machines like EC2 instances have multiple processors. So we can use or we can exploit the multi-threading capability of Python to execute a portion of code parallel using multiple processors and assign that code to be executed by one thread. So let's say there's a task which you can do parallelly, let's say reading multiple files. So in that case, let's say you have two files, there are two ways to read that file. The traditional way would be to define a method or a function and use that function to read the files one after the other. Now these would be sequential. The first file would be read, then whatever processing logic you have defined, those processing logic would be executed on the records in the first file. Then once that is done, the second file would be read. But as you have two files and you are doing the same processing on both the files, you can actually use multi-threading to read the two files parallelly, because there are multiple CPUs or multiple processors in your machine. So that would make the code execute faster. So that is the whole and sole purpose, to reduce the execution time using parallelism whenever possible. So this is an important thing to remember. So it should not be the case that you use multi-threading in all the cases. You will be only using multi-threading whenever it is possible, whenever you know that you have to run the same block of code on multiple different objects like files. And threading library or threading module is used to implement the multi-threading in Python. Now, when I say library, it is similar to module. So we'll have to import threading module in our Python code. So let's take a look at the steps of multi-threading. How do you implement that in Python? So again, this is the block of code. This is the code actually that we want to write. The first thing that we have to do is that we'll have to import the threading module, which is basically import threading. Most of the times we'll be importing all the functions of threading. Anyway, the number of functions are not that high in this particular module. So once the import is done, we'll have to define function to write the block of code that needs parallel processing. As I told you, let's say file processing. In fact, in our hands-on also, I'll show you file processing only, wherein we'll have multiple files and we'll read multiple files in parallel. So I'll have to use function to define the block of code that needs parallel processing. And it can be a function or a method also, because I'm using plain simple Python, not classes and objects. So that's why I'm using the function definition rather than method. So here I have defined the function, and let's say the function takes one or more arguments, in this case argument 1 and arg2. Then what we have to do is that we'll have to create threads using threading classes thread method. So we'll have to use threading.thread and we'll have to pass multiple arguments in this method. And what are the arguments? First, we'll have to mention the function that we have defined in step 2. So step 2 is this one, use functions to write the block of code, which is this function, and the name of the function is actually func or func. Then if the function needs any argument, we'll have to pass those arguments also. And the code would be something like this. We'll have to use a variable. So basically we are creating an object using threading.thread, and inside of it we'll have a keyword called target, and we'll have to mention this keyword. Target should be the name of the function that we want the thread to execute, not the entire code, only the portion of the code that needs parallelism, which has been defined using a function, and the name of the function is func. That would be passed, that name would be passed in the target keyword. So here you see target equal to func. And notice that I have not used the open bracket and close bracket here, because that is not needed in the syntax. We do not need to pass the open bracket and close bracket. And then we'll have to pass the arguments to this function. Now in this case, there are two arguments, but because of space constraint, I have just mentioned one. So using args, we mentioned the argument. So arg1, then comma arg2, and then also comma. That is the syntax. So here we are saying that create a thread to execute this function. And what is the function? This is the name of the function, func, and the function takes these arguments. So a thread would be created to execute this function. So once that is done, we'll have to start the thread. So after the thread is created, we'll have to start it using t.start method. And t is the object. So this is the object t. So we'll have to use this object to start the thread, and then we'll have to wait all of the threads to be completed before ending the program. So then we'll use t.join method, and what it does, it waits for all the threads to be completed. Now of course the question is, there are not many threads that I have created, right? So how many threads would be created for this particular program? Of course we have not mentioned the number of threads here. So in this case, the program would create, or this particular code would create only one thread. It will not create multiple threads. If we have to create multiple threads, we'll have to use loops like for loop. Using that loop would be creating multiple threads and will execute them parallelly. Alright, so let's see some hands-on of multi-threading.